Ladies and gentlemen, thank you very much for your attendance and for your patience. I'm sorry that we're a little bit late starting this final keynote session, which was due to the slightly late closure of one of the streams earlier, but you're all most welcome, and thank you very much for coming along to what I'm reliably informed is a meeting of IT and heavy metal. So we are very honored to have with us today for our fourth and final keynote of the day, gentlemen from CLAAS, both by the name of Christian. We have Christian Schäperkötter and Dr. Christian Rusch. Please give them a warm welcome as they tell us a little bit more about if agricultural machines talk to each other, ways to a safe and standardized networking. A big warm welcome for them, please.
Thank you.
Thank you, Christian.
Well, thank you so far. I'm the first Christian, the second one, Christian Schäperkötter. I'm not here on my own. With me is Dr. Christian Rusch. We will try to share the presentation for the next 20 minutes a little bit. Your job, Christian, will be more or less the technology aspects, and I will try to give you a first impression concerning those, let's say, commercial aspects and a little bit of strategic input. Well, what you see above is already what we are discussing about most of the day. You might imagine horsepower, throughput in tons, not only in megabit. Those are the dimensions we normally work with. And well, within the next 20 minutes, we try to get a link to the Farming 4.0 scenario. And therefore, we divided the presentation in 4 main parts. The first part we will try to build a kind of bridge between the traditional, or more or less traditional, Industry 4.0 scenario and what we need in the farming or in the ag domain, agricultural domain. Second will be then a more technology-focused chapter. Christian will introduce to you the telemetry and machine optimization aspects, and then we will both try to walk, let's call it a path where CLAAS will need to develop in the next years to get to this Farming 4.0 scenario. We'll also show some first impressions what we do or already did this summer in the harvest, during harvest, the last weeks and months. And finally, this, of course, will lead us then to a kind of conclusion. Well, first of all, Industry 4.0, Farming 4.0, what does it mean? I don't want to spend too much time on this, but talking of industrial revolutions is for a manufacturer like we are something that meets our own history. So CLAAS is around about 100 years ago old. That means we came up with this second or third industrial solution. We are facing, of course, in Hasewinkel or in the other production sites, things like assembly lines and stuff like this. Well, for a couple of years, no, decades, I guess I have to say, we're now working on those IT-based services, system-based services, and finally, throughout the last years, focus as well on those networking aspects in the farming or in the fourth industrial revolution, and try to adopt this to our farming use case. Well, let's move in 2 or 3 steps towards what's the big difference between normal, or let's say state-of-the-art Industry 4.0 or this connected network aspect. Both of you, or most of you, will know this smart home, let's say, use case. You're very familiar with that, having networking devices, having a full integration into, I don't know, iPad controlling and stuff like this. Not really our use case, what we are working with. Maybe a little bit closer already, the car-to-car use case. Talking of vehicles, very important for us as well. The machines we are building are moving. They are not fixed to the ground. What is maybe a little bit different is that we are talking a lot of cars, or that our machines are networking together, trying to reach a common name. While we're talking here more about, let's say, infotainment, or, for example, how to handle dangerous situations between different participants. coming a little bit closer, then having those traditional or this typical automation use cases somewhere in a kind of production with all those information the different machines are sending. For example, logistic aspects or informations like shipping times or capacities. Those informations are very, very relevant for us as well. You will see that later on, which then try to optimize those material flows and stuff like that. Well, of course, you might imagine this is for the agricultural domain a little bit different. We're talking, on the one hand, of moving entities, and just to put it a little bit closer right here, as well of mowing entities. This is a farming 4.0 scenario from the Netherlands, where an entrepreneur tried to connect all the different cows in a herd together to find out, okay, which cow do I now need to care about in a very special way. For example, because this cow has fever or something like that. Quite interesting for us, 200 megabytes of data from one cow, okay? Now trying to leave the cows, trying to get into our domain. What you see right here is a kind of map, a typical map of a farmer or a farm, where there are different areas of farming, different fields he is working on, where we have different machines as well. And this is very important for the things Mr. Rusch will explain later on. These machines interact with each other. These machines interact as well as a combination of tractor, for example, made by CLAAS, and a different implement, for example, made by any different manufacturer, in this case, Amazone, an implement manufacturer 40 kilometers away from us. And all these participants need to deal then with the informations that come up from the process context. For example, right here, informations about wind, very important if you put fertilizer or on the field or if you spray. For example, about ground conditions and the way you worked with the ground, something like here. And then finally, if you go through the year, very important for our core machines, the harvester, who needs to get the information about, for example, the fruit on the field, the condition of the fruits, and very important like this, and this year especially, how much rainfall before, to set the process in the right way, and very important as well to put up the logistic chain in the right way. This was a little bit the first snapshot of our use case. We're already working on process optimization, especially optimization in such fleets today. We're doing this with a couple of services and a couple of technologies. Christian Rusch will now introduce two of these technologies to you, talking of telemetrics and CMOS. Christian.
Okay, thanks. On the first, I want to, for single machine optimization, we have really good products. The name of these products are easy products, and easy is efficient agriculture systems. For example, here you can see our CMOS system. The system is to adjust the machine, the combine harvester, the machine parameters of the combine harvester autonomous. Because it adjusts this machine optimal for all harvest conditions, you need a lot of knowledge. And in agriculture, we have the same problem or the same challenge, the skill shortage like the industry. With the CMOS system, the driver of the combine harvester have to choose a harvest strategy, fast, high quality, or fuel consumption, and so on, and the machine is automatically optimized. We have a standard telemetry system over 10 years in the market. The product name is telematics. The technical function is a standard M2M solution. The agriculture machinery is collecting data, for example, GPS position, temperature, oil pressure, and so on. And if the machine has an internet connection, every 5 minutes, the compressed data will be transferred over GPS to the CLAAS telematics web server. The customer can analyze the machine data and optimize the process. But this process optimization happens only in the post-processing, not direct in the harvest situation on the field. In agriculture, is standardization a necessary requirement? Because in agriculture we have heterogeneous machine fleets. One solution is the isobus. This is based on a physical CAN bus, a communication interface between a tractor and an implement. Here you can see the communication between the tractor and the baler. With the standardized interface on the implement, it is possible to receive all important performance and harvesting data, not only tractor data. And this collecting data will be transferred over GPRS to the CLAAS telematics web server and documented and analyzed. But here you can see our world record in 2011. We harvest over 80 tons per hour with a single combine harvester. To get that performance of that single machine, you need a lot of logistic partners in the process. For the world record, we need 5 tractors and 1 telehandler, 2 combine drivers and 8 tractor drivers. But no farmer has this logistic machinery on his farm.
Just a sec. Maybe we can spend 2 or 3 more words on that. That means for the operator of this harvester, this Lexion 770 Terra truck, if he wants a running logistic chain, he has to provide as well 5 tractors with all of these logistic trucks and whatever needs to be provided as well in the back to ensure that that we can build up the whole logistic chain. That means as well that most of the tractors wait most of the time, right?
Yes.
Okay, just to point out the potential right here.
And so our customer have a gap between the installed performance, the 80 tons per hour, and the realized performance that are only 30 or 40 tons per hour of our machines. To close that gap, we need smart services and smart technologies.
Aiming on 40 tons per hour.
Yeah. Okay. And in the next slides, I will explain some of these smart services and smart technologies that we developed or that we use. This year we test Farming 4.0 on the field and see the drivers and the requirements of the market and analyze this information. The size growth of the machine largely exhaust the technical limits, and government regulations don't allow bigger machines. I explained before, the focus today is the single machine optimization. The world record showed that the limited factor of the limited factor is the transport logistic. Therefore, our focus is pointed at process optimization, especially the control and steering of the entire process chain and the integration of all process participants. And that's our vision. The network machines act as one unit in the process. Every process partner are connected to the process network. The customer has only to define the process objective, efficiency, speed, time or the fuel consumption. And then the CLAAS machines work together on the field and achieve the defined process objectives. For a network machine, we need M2M connections or M2X communication. The ability for communication within an entire process is of high importance, with or without public available infrastructure. The most important requirements and constraints are here. The first is in Europe, we have only heterogeneous machine fleets. So we have to standardize this communication between the machine on the field and to the infrastructure. The next challenge is the communication is not always given. In rural areas, we have, is it not always given, this infrastructure communication. And the next challenge is the global availability of mobile communication. The different standards and frequencies, we have solved that problem. And the last one is the secure communication between the machines and the servers and so on. In the next slides, Mr. Schäperkötter will explain some applications and solutions. Okay.
Yeah, thank you, Christian. Dr. Rusch already pointed out that we have already today technologies, for example, aiming on this combine harvester, sending out the information by a telemetric system home to the server. He already as well pointed out that we need to connect all the machines to get this huge potential for process optimization there, and that we need some more aspects, some more technology solutions for this M2M scenario. And within the next 3 slides, I will try to explain how CLAAS tries to discover this potential. So keep in your mind this use case, having, for example, 2 combine harvesters right here, an infield logistic tractor right there, and a couple of trucks at the street or on the road, trying to bring all those, wheat back home or bring it to the mill. So we first focus on trying to create transparency for all participants, especially to those who really need this information. For example, it's nice to know for this combine harvester how full the grain tank is. It's very important to know for this tractor to get this information, because he is the one to decide, do I first try to get all the wheat from this combine harvester, or do I first drive to this one and bring then all the wheat to the trucks on the road. So first step for us, try to create transparency, especially transparency not only for big machines like here, but as well for those machines that we see out there in the processes of our customers. And that means as well that there are not only those nice seeding green machines called CLAAS, but as well maybe appear some machines from our competitors that we have to get into the process, for example, by using the Isobus standard Dr. Rusch already introduced to you. So first, transparency, then second, of course, if we got all those information, try to get into this assistant use cases. For example, to give you some easy examples right here, trying to point out where the meeting points, the rendezvous points between this tractor and this combine harvester might be. Trying to use the information the combine harvester is producing all the time and mix this together with the information of the tractor concerning, for example, the location. And then leading step by step, service by service, from data, just pure data collection that we already have today, to different kinds of planning or assistant in planning, to especially what we saw in the field before, ways to optimize logistics, performance in logistic processes, and monitoring the different operations there, and then step by step try really to get into the different chains, and as well get into, for example, the next chain. What we see right here is already the following process after harvesting all this wheat of well, plowing or creating already the basis for the next seeding period. All this, of course, needs a very intensive interaction with our customers. New, more or less, for a machine manufacturer like CLAAS, but of course, there's a first solution coming out as well. Last year, we launched a so-called 365 FarmNet portal that brings together different manufacturers of different, let's say, services in the agricultural domain. I will show you some examples later on, and trying to give a portal that accompanies the farmer all around the year with some more or less ERP functions, but as well some functions to optimize then processes in the field. So much more than a traditional ERP system. And as I just promised, to give you some examples right here, trying to collect services, system-based services from the producers of seed, then trying to integrate this implement manufacturers. We already had this example of Amazone, trying to get the producers of fertilizer and stuff like that, for example, Bayer right here, as well as third-party service providers like the Allianz here, who provides us with satellite data and stuff like this. All of this then needs to get together, come together to have a really, let's say, full customer-orientated solution for this farming 4.0 scenario. And hoping to introduce this scenario to you within the last 24 slides, we now come to our conclusion. And if you still then have some open questions, we might discuss them then finally. So conclusions from our point of view, from the industrial point of view, well, we're traditionally talking about, as was already mentioned in the introduction, we're talking about heavy metal traditionally, but today more and more talk about as well smarter or smart farming aspects and networking machines, not only about telemetrics. And what is getting obvious during the last years is that this traditional system boundaries between machines, humans, and the environment fall as well in our domain. This leads as well for CLAAS, it's a little bit new, to a new kind of interaction between us, different competitors, and our customers. And well, already mentioned, those technological aspects like a safe and stable infrastructure must be given to realize these new scenarios. We are working on new distribution and delivery channels to integrate our customers and as well our competitors. And well, if we manage to do this, we are quite confident that this leads to a strong CLAAS market position, especially due to the fact that we are aiming, of course, on the top of the market and on a premium product. So far from us, I guess. Christian, anything else to add? And feel free to ask any questions. Thank you.
Thank you, gentlemen. Don't go, just in case we do have any questions. Is there anybody from the floor who has a question for CLAAS? I did. One of the things I wanted to know, you talked about the drivers for this. One of the things that interests me is this kind of top-down or bottom-up? Is this coming from the technological capabilities that you can take to your customers and impress them by what they can achieve? Or is this being driven by customers bringing to you problems and situations for which they need a solution?
It's both. On the one hand, of course, there's a technology that's available now. You did your PhD on that, but you brought it as already on a farm. We brought it on a couple of farms this season as well. And then, of course, both met. On the one hand, the technological capabilities, and on the other hand, for example, as we were talking of taking all these test scenarios, test equipment back to Hasewinkel, our customers told us, hey, please do not do that. Please come back next year. We have some new machines here, let's try it there as well. So it's a little bit of technological push. Of course, there's a kind of initiating stream coming from the R&D departments, but especially our professional customers aim on such assistance systems, aim on getting help in their processes due to the fact that the processes are quite complex.
Is there anything you would add to that?
The first step was we interviewed the drivers and the farmers.
Yeah.
That was the first step for us. And then we know, or we think about the technologies and how we can solve this challenge of the drivers and the challenge of the farmers.
Yeah. Well, gentlemen, thank you very much for your time. I found that fascinating. Please give them a big warm hand.
Thank you.
Thanks very much.
Okay.
Thank you, Christian.
Thank you.